Today, children, we're going to learn how to do stoichiometry. And stoichiometry is something that a lot of people struggle with, especially because of math. In this question, number 1, how many moles of CH4 must be combusted in the presence of unlimited oxygen to produce 2.5 moles of H2O? So this is overly worded, so it's just asking how many moles must be used in the presence of unlimited oxygen, which means if oxygen is unlimited, to produce 2.5 moles of H2O. So right now we're going to start with 2.5 moles of H2O, and that works out pretty well. What we're going to do with this is that we know here 2 moles of H2O is going to equal 1 mole of CH4. There's no number in front of here, but we can always assume that it's 1, because if it's a 0, then why would you even bother putting it in? Continuing onwards, you would grab this thing and this thing. You can't really see my finger, my cursor. And write 2 moles H2O. And you get 1 mole of CH4. This is the part where you write down, if you already have moles of something and you're trying to figure out how many moles of something else must be there, this is your reaction. It's ratios, 100% ratios. If the ratio was 2 out of 1, 2 being H2O and 1 being CH4, then 2.5, what is that gonna be? Well, I don't know, 1.25. But we don't know that yet. We're using this method, so then when we use bigger numbers that we have to do it, that we can't do, like 63 to 41, it'd be a lot easier to convert it. And the way that this is written, it makes it easier for you to be recognized. This has been scratched out, and this has been scratched out. The same way that if you were to write 1 multiplied by 2 over 1, the 1s are going to cross out, and you're still going to get 2. Yeah, they're crossed out and you're only going to get 2. Why? Because they don't exist anymore. You get rid of this label, and then that means you're only going to have this title left. When you have this title left, we can do 2.5. Let's see. 2.5 divided by 2 equals 1.25 moles of C4. Is that what we predicted? Yes, that is. The reason why this works is this is a 1. Whenever you see a 1, you cross this out. And hopefully I can get better at explaining it in the next question. But 2.5 divided by 2. You cross out this, you cross out this, you cross out this. This is a 1, so you cross out the 1 too. What's left? You have 2.5 divided by 2. Do that quick math, boom. 1.25 moles of CH4. And if you look at the ratio, 2 for every 1, 2.5 equals 1.25. That is correct. Now let's move on to the next one. How many grams of O2 are needed to produce 1.5 grams of CO2? So we have CO2 up here. This guy is a single man. We're going to write that down. 1.5 moles of CO2. You're going to think it's annoying, but you absolutely should be rewriting. It's a way to stay, organized and stuff. Again, obviously, what is in the ratio? Well, let's see. We have CO2. Now, the thing is, we got to get rid of the CO2. What do? We got to put the ratio down here. So CO2, 1 mole of CO2. It's going to be down here. And then it's asking how many grams of O2 do we get? No, do we need? So let's look at the ratio here in the original equation. It says 2. So then it'll be 2 moles of O2. If this is moles of CO2, then it has to be down here too. Take this example. 1.5 to 1. Oh no! Would you look at that? These guys are crossed out. Oh wait, this guy's a 1. You cross him out too. What's left? Because this is above the thing, this division sign doesn't actually exist. So if it's above the line, you multiply. If it's below the line, you divide. That's one way I remember it. So then in this case, let's grab our thing, 1.5 times 2. 3. Now let's see if that's true, ratio-wise. Again, this only works for smaller numbers. Once I get into bigger numbers, that's gonna hurt like hell. You have, the ratio is 1 to 2. If you have 1.5, that makes it 3. Makes sense? See? 2 divided by 2 divided by 2. Okay, that makes sense. But now, oh shit, what happened? Now that we have that result, 3 moles, we have to figure out grams. If you don't know, moles is always the middleman. You can go grams, liters, particles, don't ask, to moles. Then moles can go into other moles. And that mole can go into the same exact thing, grams, liters, and particles. Again, it does not make sense. Why? Mole is the middleman. Just remember that. Now that we have it in moles, we're all set. We can figure it out. For 1 atom of O2, we gotta look at the molar mass for this. Molar mass in this equation is gonna be, okay, you can write it here. Because we already know that's going to be the result we're going to add on to it anyway, so we can write here. 1 mole of O2 is how many grams of O2? Look at the reference table or simply look it up. I am looking it up because I'm too lazy right now. 16. So 16 is for 1 atom of O2, of O. Now, oxygen equals 16. If we have 2 oxygens, that equals 32. Does that make sense? Because if you have 16 plus 16, that equals 32. Exactly. So then let's continue on with this work. And 32. Okay, great. Now what do we do? Oh, look, it's a 1. Oh, look, it's a moles. And look, that's the same thing too. You cross out the same exact things. What do we end up getting? 1.5 times 2 times 32 equals 96 grams of O2. Again, this is the mass, molar mass for O2. And you're scratching out everything that matches in anything that has a 1 on it. This has a 1, this has a 1, this has a 1, this has a 1. Another thing, if it's above the line in the equation, you are going to multiply it. If it's below the line, you are going to divide it. But remember each time to click equal, equal, equal. Because if you have a really specific thing where you have to divide and then multiply, divide, then multiply, it's not going to work out. All of these are on top. That means all we do is multiplication. And we get 96 grams of O2. Let's continue. How many grams of O2 are produced? 117.5 grams of C4, CH4, not C4, when oxygen is not limited. So not limited, which means it's unlimited. Again, they like to confuse you. They like giving big words. Don't ignore that. When oxygen is not limited, that means when oxygen is infinity. And there's always an amount of oxygen no matter what. You're never going to run out of oxygen. So then let's continue this. How many moles of O2, O2 is what we need, are produced, yep, when 117.5 grams of CH4 combines with oxygen, and oxygen is unlimited. 117.5 grams. Remember, you gotta label everything because life sucks. Oh lord, let's write our next equation. What do we do? What are we trying to get? Well, currently, let's look at the map. We have grams, liters, particles, up to moles. That goes to other moles. That goes to grams, liters, particles. Oh great, we are right now at grams. Where do we have to end up? We have to end up at moles of a different thing. Imagine there's like an imaginary arrow here. Moles of a different thing. Okay, that means we're gonna go this way, and we're gonna go that way. One equation, two equations total. Let's do that. That sounds fun. You have my little friend over here. How many grams of CH4 equals 1 mole? Because we gotta get from grams to moles. Okay, 1 mole of CH4. Oh no, it looks like we have to do the same thing here. And we are. So we always know that hydrogen is gonna be equal to 1. So if there's 4 hydrogen, that means there's 1 times 4. Okay, that's 4. Easy peasy. And then there's only one carbon, which means, let's see what number carbon is. Yes, it is 12. Okay, I was right. And then we're gonna add these two together. What do we get? 16. Okay, easy. Simple math. 16 grams. Okay, now let's cross out the stuff that we already know. So what is our title label gonna be? It's gonna be 1 mole of CH4. Obviously, that's not what we want, so I'm gonna go take a step ahead and try to remove the mole of CH4. We'll get back to that later. So we have 117.5 divided by 16. Boom, 7. Close to 7, at least. 1 mole of CH4 equals 2 moles of H2O, which means the ratio is going to be 1 mole to 2 moles. Oh, well, would you look at that? Look at the happy little family. Okay, now let's do the same thing again. Cross out the stuff that's 1. Cross out the stuff that's the same. What do we get? Let's see. We have 17.5 divided by 16, but then you gotta multiply that by 2. Okay. So then our result is gonna be moles of H2O. Is that what we want? Yep, moles of H2O. Let's try again. 1.7 divided by 16 multiplied by 2. Would you look at that? That looks like around 14.7 moles. Nice, there's our answer for the second one. The last question, let's see. How many grams of O2 are needed to produce 562 grams of H2O? So what do we have? We have 56.2 grams of H2O. Great, now what do we do? Well, we gotta get rid of the H2O, don't we? So let's grab the H2O. How many grams equals a mole of H2O, though? 18. How does that work? Well, O has a molar mass of 16. H has a molar mass of 1, multiplied by 2 because of that little guy. What do we get? 2 plus 16? 18. Let's erase all the things that are the same. Cross, cross, cross. Cross, cross, cross. And that one says 1. So then we're going to end up having moles of H2O. Do we want moles? No. We need grams of O2. Well, let's look at the chart. We go grams to moles. liters to particles to another mole. Do the same thing. Grams, liters, particles. We started here. We gotta go here and here, and then gotta go to grams. So 1, 2, 3. We have 3 equations to do. That's just our first equation. I know, looks a lot, but don't worry about it because you can really simplify it by a lot. I don't want moles of H2O. Well, let's look at the ratio. H2O has 2. O2 has 2. Oh, that's so weird. 2 moles of H2O and 2 moles of oxygen. When the top and bottom ones are the same, you can cross that out completely. Like literally completely cross it out. Why? Because if you were to do the math, 2 divided by 2 is 1. So you're not gonna, and then multiplying, replacing this equation, having 1 next to it, we know anything times 1 is gonna be it itself anyways. So we can cross all of that out. Wow. You should still probably should work for it. Okay, great. So now that we cross this out, we can cross this out too, because technically they're the same. So then 1 more equation left. I'm sorry guys, but remember the map. We have 3 equations to do. 56.2 grams divided by 18 grams. But now I have 1 mole of O2. 1 mole of O2 is going to equal to greater than 2 grams. Yeah, math-wise. Good, smart math. Let's do it. So this guy's below the line. We divide 56.2 divided by 18. Wow, that's a big number. Okay, well then we could skip this step because it's 1 anyways. Now let's go over here. We already have this scratched out because of this. There's 1 scratched out here. And that's a 1. So that means we gotta multiply by 32 grams. So times 32 grams. Oh, look, we have about 99.91 repeating grams of O2. Congratulations, you have learned something new today.